Morning, everybody. Sorry for the technical issues, but thank you everybody for joining. My name is Tim Hoxma. I'm the marketing director here at Oakwood Systems, and we have a conversation this morning where we're going to be talking about high-performance computing on Azure. We have a couple of our principal engineers from the Oakwood team, Daniel Cook. He oversees our HPC group, and then Michael Kaler is our senior director of Azure Infrastructure and Data Center. This morning, we're going to walk you through some of the conversations that we're having with our clients, as well as trends in this area. And again, thank you for joining. If you have any questions, make sure to post them here, and we will get to those. I think we anticipate about a 30 or 35-minute conversation with some room at the back end to handle any Q&A. So I think we're ready to get started. Dan, Michael, do you want to take it from here?
Yes, thank you, Tim. I think Dan will start us off here on these first few slides.
Yeah, quick overview here, a little agenda based on the topics that we will discuss this morning. Some Cycle Cloud, some of the storage challenges and opportunities, and specifically around the HPC schedulers, and then benefits within Azure that you can take advantage of. A couple of the things that our clients are talking to us about is in regards to, the access to latest and greatest in regards to both CPU and GPU access within Azure. As the chip manufacturers are developing and creating their new chipsets and making them available, they are being deployed and built within the Azure cloud, giving customers the ability to both scale and utilize and test on demand, and giving them that ability to get quick access to those. Ability to use and pay only for what you use, and no upfront high infrastructure costs in order to be able to build that in your on-premise data centers. One of the big things that Microsoft has done in regards to the HPC availability within Azure is to develop an application called Cycle Cloud. This gives you an interactive and GUI-based interface to be able to structure and set up the clusters and workloads that will allow you to run your HPC structure directly within Azure. Cycle Cloud itself gives you the framework around structuring all of that. So it gives you the ability to stand up clusters, stand up your nodes. They are bringing in more and more storage options so that it'll make it simplified and easier for customers to be able to stand up those structures and not have a need for on-hand, on the keyboard, coding and deploying all of this. Some of the key features around Cycle Cloud, this is a little noisy. We can make these available afterwards. But some of the big things to take away here is flexibility and customization. The ability to stand up different VM sizes, put them in different regions, and have all of that configuration in one spot that can be managed and maintained from a technical perspective. Dynamic scaling. As the job sizes grow or the availability and submissions of those jobs continue to increase, being able to dynamically scale the clusters that are being built there is one of the largest things that our clients are looking at. Not even just to grow, but also once the job's complete and finished, being able to scale that back down, making sure that clusters are turned off in order to reduce that cost of utilizing them. The other big availability here is both hybrid and multi-cloud capabilities. If you have already made investments and you're running your HPC workloads on-premise now in your own data centers, being able to burst through and access the cloud from a perspective of only turning on those clusters when they're required. You already have your jobs that'll be able to run within your own data center, but that capacity is limited. So the ability to scale out and burst up into a cloud and use that hybrid setup gives you that greater flexibility to be able to manage the resources that are available. And then, of course, security and compliance kind of goes around all of this, making certain that only those that can access or need access to get access to what they should be able to control. The integration within Entra ID, a little outdate there, little typo. But Entra ID can be integrated into all of this so that your users have that seamless control within regards to being able to access the environments. Some of the use cases that we've been working with our clients on, bioinformatics and genomics, being able to run, again, a lot of the clients that we work with are in that hybrid mode. They have investments in an on-premise cluster and data center, and they want that ability to be able to burst out and utilize some of the newer technologies. Not all of the on-premise hardware is the latest and greatest, so being able to access that, specifically in the GPU areas. A lot of the chip manufacturers are getting their GPUs into Microsoft Azure and being able to utilize that specifically from even the visualizations and graphics when doing some work there. And then rendering and visualization. A lot of the media and entertainment industries use both Azure Cycle Cloud in regards to spinning up and turning on the clusters when they're working on them. So they do all of their initial setup creations and then just utilize and spin up and start the clusters within the Azure environments as they need them. It could be only specific months when the rendering is being required, and then they can turn those off and turn them down so that they don't have to do any overpayments and structure in there. The other thing in regards to rendering and visualization is in regards to data storage, which we'll talk on a little bit more in later slides. Some of the storage options that are there are the multi-parallel file system options. Lustre, NetApp files are two of the big ones that are there. There are a lot more coming into the environments now. A few that we've been talking to and working with, Hammerspace, Weka, to name a couple that are very big in the parallel file system setup, and structuring those so that you utilize the best practices in regards to both data management, backup and recovery, and the storage that you can manage there. Some challenges that we've been working with from a client-based perspective, and it's across all industries that we're noticing. One of the biggest ones is data growth. With the amount of data that is being accessed and pulled in and utilized is exponentially growing, and the control around that and being able to segment the hot from cold data is a big concern for a lot of clients. And then obviously accessibility. As we continue to grow and groups are working globally around with both clients and customers, and then being able to access that in a timely fashion. How is that structured? Where's the networking set up? And again, security being who has access to sensitive data, making certain that there are structured backups and recovery mechanisms that are built around that, not just from data is always available, but data is also there should multiple data centers go down, which I'm sure Microsoft would not like me to say that, but it does happen from time to time. There are some issues in regards to being able to access data. So making sure that that is structured and set up so that it is always available. So in regards to the parallel file system, it gives you that ability to basically provide high-speed access to the data, specifically around the HPC-based community, being able to run multiple clusters, and from a parallel-based perspective, being able to concurrently access all of that in a timely fashion. There are challenges around always having that accessed based on regions that could be set up in regards to both compute and data storage. But there is ways that we can structure that so that there's limitations on the, not limitations, but accessibility for all of the compute base to be able to access file systems. Some of the basic ones, a lot of us know about that. From a scalability perspective, making certain that data is in all different locations as it grows, striping across different regions and different devices, being able to both read and write concurrently, and then fault tolerance, making certain that there is that redundancy built into there. Again, some of the parallel systems that are very popular right now, Lustre is a very big one. GPFS is one that a few of our clients are utilizing, and then a few that haven't been mentioned that are tops coming out now. Hammerspace, which we are working with in the media and rendering environment, and Weka, which is another up and coming large group from a parallel file system that you can utilize. The Lustre file system is one that has a lot of popularity. Very high in performance, very well structured in regards to doing a distributed large scale cluster. It does this in regards to being able to split both the metadata and the object storage. Metadata can be spread across multiple regions, multiple locations, and it has the ability to quickly understand where the objects are and be able to retrieve those in a very efficient manner. It is an open source setup, so it's constantly being developed and being built upon, and the support for it is very large within the Azure community, and the majority of the groups are starting to adopt this a little bit more and going away from standard just storage accounts within the Azure environment. The other big one that we've started working with a little bit more now is Azure NetApp Files. They have been around for some time now. Their big one is their high performance. They have a very low IOPS and low latency configuration and build out. Their security is very top notch. They have put a lot of work into that in regards to making certain that it is both encryption at rest and in transit, and the ability to be able to integrate it with Entra ID. The scalability is both vertical and horizontal, so you can scale both up in regards to the data sizes, and you can scale out in regards to the number of nodes that will manage and maintain the ability to access that data. Some of the use cases for NetApp Files that we've been working with, and we've seen a lot of clients that are using NetApp files with in regards to large-scale simulations. ANSYS CFD is one of the large ones that clients are using and using NetApp files with. And AI and ML workloads are adopting it more now. We're seeing a little bit of a growth in that area. So some of the best practices around keeping your data both secure and highly accessible, making sure that the keeping regular backups. One of the things that a lot of our clients go through in regards to backups is bi-yearly data recoveries to validate that everything is there and working. Version controlling, tracking changes, being able to roll back the necessary changes that customers did that they didn't want to maintain. Some of the access controls in regards to being able to validate and reduce the number of users that have access to certain data, and then setting up those to be able to integrate that into whether it's your Entra ID or another identity management system. And one of the biggest ones is optimization, being able to review and understand where bottlenecks are coming from and being able to reduce and eliminate those in regards to getting both faster and better performance. Faster isn't necessarily always the thing that you're looking for. It could be increases or changes in regards to write speeds or anything like that. Lifecycle management, we work with a lot of clients in regards to data retention, data archiving and movement, and deletion policies. A lot of groups need to maintain certain data for certain lengths of time. Being able to structure that and set that up in a fashion that allows them to maintain their credentials in regards to those policies. So moving into some of the schedulers that are available, there are a wide range in regards to the availability of those and the importance in setting up and structuring those so that users have the ability to submit jobs and access those in a fashion that works for them, whether it's on demand or it's future-based jobs. The performance of those schedulers is one that needs to be able to both control and maintain and manage a high level of efficiency and throughput. And then in regards to being able to architect the compute nodes and the partitions and the clusters that are configured and built and accessed from those schedulers so that jobs are managed and maintained in that timely fashion. Just kind of reiterating in regards to the breakout of those schedulers. Some things from a configuration standpoint, the fairness in queue management. Everybody likes to say that their job is top priority and has to get done ASAP, but being able to manage and maintain that in a fair and equitable manner is something that can be built into the schedulers. Obviously, you can put prioritizations around which jobs are allowed to jump the queue and not allowed to jump the queue. Time management is one of the ones that are great. Being able to schedule jobs that can not necessarily run right away, but maybe can push to off-peak hours, run overnight, and give the users their results next day when they return to the office. And being able to reserve the clusters and nodes in specific time frames, knowing that in 2 weeks, specific information has to be built and structured, and being able to reserve those nodes at that time. Also, you can build some fairly complex workflows. There can be multiple steps, multiple tasks that can be built into the job workflows, and being able to build and structure prerequisite data files or structure and set that information before subsequent tasks have to utilize and access that. Some of the flexibility around that, as we were talking about, gives an organization those tailored policies. And we work with a lot of clients to be able to structure those policies depending on the schedules that they utilize and work with. Integrated into CycleCloud already are several different schedulers. You can see here, LSF, OpenPBS, and Slurm are some of the biggest ones that are being utilized right now. Gives you the ability to come into CycleCloud when it's running and start to build and structure and work out the configuration settings in regards to how those are handled. You also have the ability to stand up some of the file systems. Microsoft is constantly increasing and growing this. I know they are working with Hammerspace currently, so that's one of the ones that may be coming in the future. The ability to be able to just stand up single VMs. This gives clients an opportunity to create a VM that will allow users to sign into, log into, and structure and build their jobs to submit into their schedulers. If there's not a direct network access or connectivity into the Azure cloud, you have the ability to stand up standalone VMs or even Azure Virtual Desktop environments to be able to connect to those cluster schedulers and submit your jobs. So moving on to Slurm. Slurm is one of the ones in the industry right now that is being widely utilized. It is an open source environment that gives you the ability to stand up and structure both the clusters and the job submission. All of this can be, as I was mentioning, structured and built through the CycleCloud environment. It gives you the ability to create and structure your scheduler and then have your scheduler ready to be able to deploy jobs onto the partitions and spin up those partitions. One of the greatest things in regards to all of this too is that you have the ability to connect to any other Azure service, whether it's a structured file service, from the networking in order to be able to control where the access is and who gains access, be able to segregate that off to Entra ID so that users can use their direct login, their standard logins in order to be able to connect to and submit jobs. All right, next slide, Tim.
All right, so I can chime in here, Dan. So talking about our next piece here, guys, a little bit less on the technical side, but talking more about what does it mean to translate that to the business? What benefits does this bring to your business, to your organization? And why would you want to either scale, whether you're working on premise with HPC workloads now, and you want to scale into the cloud or experiment with it, or have never dealt with HPC in the past and how it can benefit the organization? What you're seeing here on the screen now is more about that scalability and elasticity. A lot of options we've talked about in some of the slides that Dan has gone over, but some of the things I like to call out specifically is the flexibility of it all. The ability to not have dedicated hardware that you have to maintain all of the time on premise. You can scale up, scale down, and have that burstable capacity based on what exactly your workloads are looking like. There are some organizations that operate, 24/7, have a standard dedicated schedulable workload process where they can obviously forecast what their workloads are going to look like. Far too often we have the more burstable model where, you know, certain times of the year or certain times of the day, you might be bursting that queue very, very high on those submitted workloads. Whereas other times, weekends, after hours, you know, holidays, things like that, it's not. And so it's going to scale up or down that hardware based on the needs at the time, which can translate into a lot of cost savings, which we'll cover a slide here a little bit on that. But that also gives you the ability to be able to do that in an automated fashion. And that comes with some very, very big benefits. One of which I mentioned earlier, which is obviously not having to handle the hardware or, you know, administrate the hardware going forward. But second of all is the ease of use of submitting those jobs, whether it be researchers, whether it be, you know, N-type personnel at a marketing firm, or, you know, people looking at just getting some demographics or some general distribution information on, you know, whether you're in manufacturing or whatever vertical that you're in. It makes the process that much easier to get into. They're able to submit their jobs, see their results fairly quickly, know where their position's at in the queue, and not have a lot of interaction with IT support teams to make it a lot more streamlined and easier for them to use in the long term. All while utilizing the full stack of the Microsoft process, which obviously the global reach is something I want to call out there because it doesn't necessarily have to be localized to one region. There are delivery methodologies and delivery caching things that can be done to make it a lot more usable across wide areas. We've got quite a few of our clients right now. They're working with Microsoft that have a distributed, you know, work base. They might work east to west coast US. They might work multiple countries, and they want to be able to have the same performance we do here in the States if they're operating in, you know, Asia Pacific or any other region out there. And so there are methodologies out there that don't cost a tremendously large amount more to be able to implement and be able to maintain that same performance on a global scale. All right, Tim, I think you can go to the next slide. And then we get into the cost savings and that cost of ownership. So yeah, as you guys can see, there's quite a few bullet points on this slide. Some of the ones I definitely want to call out is the flexibility in how you do this. A lot of the same cost saving methodologies that you can apply to your standard Azure tenant can be applied here. You know, things like hybrid capabilities and hybrid licensing and things like that are all things that you can absolutely put in there. You can go as a pay-as-you-go model if you want some flexibility, even as, you know, whether you're piloting it, try before you're buying it, or whether you're just scaling it up. The hybridization makes it really nice because it means you don't necessarily have to completely abandon if you are using HPC workloads on premise with current hardware and you want to do a like-for-like comparison of performance, throughput, how the storage performs, what the network latency is like, and maybe do some fine-tuning on that QoSing or anything on the network side. It gives you the flexibility to do that. The nice thing is if any of you have some exposure into Azure, you know, it's got a lot of really, really good tools in there that are baked into the tenant to give you that budget forecasting, to see what your average spend in Azure is going to be and what it's projected to spend over the next month, 6 months, 12 months. And obviously it goes off of trends based on what you're inputting in there. So you can keep a really good eye with a single pane of glass over what you're currently spending, even if you're just trying it out, versus what you're going to get in operation. And it also gives you some ability to do some crystal ball methodologies where you can whiteboard it, for lack of better terms, where you can see what it might cost you if you burst it into this area or explored with different SKUs. If you're pulling in different SKUs because you need a different workload level on your CPUs, whether you want to do some testing on some GPU workloads, it allows you to do some testing there to kind of really see what that TCO is going to be in the future. That way, if you're going to present this to the business, you know, C-level executives, board of directors, anything like that, that you're able to give a much better narrative as far as what it's going to cost and what the benefits are as to why you might want to scale this up or even convert to it altogether. Tim, I think you can go on to the next one. All right, and that gets into the GPU side of things. So a little bit newer than a lot of people have been using for the CPU side of things, and the SKUs across the board are getting a lot more available. So there's a lot more options in multiple different regions around the world to be able to start testing this out and be able to find the differences between GPU acceleration versus what you can do with just CPU-based workloads. Some of the biggest things here is it is fully scalable, just like it was before, but you get access to some of the more state-of-the-art chipsets that are out there because, to be honest, NVIDIA and AMD both want you to test on their chips and be able to use their latest and greatest GPUs because it benefits not only them, but you as the consumers looking to use those particular workloads. A lot of them, especially the newest SKUs, the ones that are about to come out and the ones in this latest generation that are currently released now, have a lot of integrated tool sets with AI. To allow you to use machine learning, to allow you to train the models, to be able to better be more efficient in how you're handling the workloads, but also to maybe give you a better insight in how the infrastructure is built, provide some recommendations, be able to deploy things in an automated fashion, but also maintain that security. That's something that's often overlooked is, AI is a great tool for innovation. It's a great tool for automation, but it also allows you to keep a secure eye in the sky platform of what's being submitted, what's going in and out. If you are a multi-organizational institute, such as some of the institutes of higher learning and colleges that we work with, oftentimes they're working with multiple different colleges with maybe the same data set that they're using for research purposes. This is ensuring that as that data travels across the multi-tenancies or multiple subscriptions with inside Azure, that everybody is adhering to the same governance and everybody's adhering to the same security form factor that is universally governed across your entire estate. I will pause there for a sec. Dan, is there anything you want to add on the GPU side of things?
No, that covers it really well. And as you say, as the chipset manufacturers are building out these, they're becoming available a lot more in different regions. There was limitations there, so it gives that ability to utilize those in multiple different locations.
Excellent, thank you. All right, Tim, I think we can move on to our last slide. And finally, last but certainly not least, is the cutting edge hardware play. So one of the nice things about this is if you are using workloads on premise, you have hardware that's at a set state. It's that set state until you do an upgrade on it or replacement of the hardware, but it is what it is. With this and the ability with everything that Dan has kind of showed earlier today with the various different workloads, not workloads, but schedulers and facilitators inside the HPC stack, you have access to the latest and greatest hardware. And you can make a change on that on the fly. If Microsoft or AMD or anybody else releases a new chipset or a new SKU that you want to try out in the scalable environment, all you have to do is go and add it into your workflow as an availability set, assuming it's available in your region at that time, and then be able to add it into the scalability and burstability of that platform. You can even create subsets, which I highly encourage everybody does, and we at Oakwood can certainly help you with that, to be able to create testbed environments, because obviously if a new chipset SKU comes out, you don't necessarily want to throw that directly into production and obviously cause some issues if it's not fully been tested. But if you're curious how the throughput's increased, you want to test your individual workloads on it, that is something you can absolutely do in a testbed environment to be able to show what it is and what the benefits are. One of the biggest things that we at Oakwood and all of our clients have utilized this for is the ability to gain all those additional information to be able to present to your organization, rather than just saying, yes, this greatest new chip that's coming out by AMD on this particular VM SKU is supposed to give us 20% increased throughput on this workload. Now you're able to go in and test it in a confined environment, actually be able to provide live metrics based on your own individual, workflows and paradigms, and be able to translate that. Like, we actually saw this level of increase on this new hardware. I think we should look at adopting this across the board. And it's not a huge amount of investment or time or money to be able to get that started and be able to do those test cycles to be able to continue to innovate and make it, make your organization, top of the line when it comes to submitting your own workflows. I think that's the end of our presentation. Dan, did you have any final comments you wanted to add before we get into a Q&A?
No, I think we're good.
All right. Well, we thank everybody for your time today, being able to attend this today. Tim, do we have any questions that we need to address in the chat?
I do not see any as of this time. I will, let me take a look at the Q&A just to make sure. I do not see any questions as of right now, so I think we are good. Thank you all for joining. Thank you, Michael. Thank you, Dan. I'll be sure to reach out to all of you and share this deck with you. If you have any questions, be sure to respond to that message, and I'll be happy to broker a conversation with either Michael or Dan, and we can handle those questions on a one-off basis. Appreciate everybody's time, and we look forward to you all joining us next time. Thank you.
Thank you, everyone.
Thank you.